In this video, which shall know what is MOSFET, how does it work, how is depletion mode formed, how is enhancement mode work, what are characteristics of MOSFET, different between MOSFET and BJT, application, and the rest. In previous videos, I talked about how almost field effect transistor was impossible. I have also talked about FET, so do watch it out. The word MOSFET stands for metal oxide semiconductor field effect. Is a type of FET with an insulated gate that is assembled by controlled oxidation of the semiconductor. Main working principle of MOSFET is to control the voltage and current which is flowing between the source and drain. MOSFET can either be N-channel or P-channel. Its construction consists of substrate silicon layer, which is lightly doped, upon which two heavily doped semiconductor material is laid on top. Then an oxide material is laid on top, which therefore terminal source, drain, and gate are attached. P-channel MOSFET consists of light-doped N-substrate material with two heavily doped P materials, which under conduction forms a channel. N-channel MOSFET consists of a P-type substrate with heavily doped P-type semiconductor material. MOSFET P and N channels can either be in enhancement mode or depletion mode. In P-channel, holes are majority carriers which allows for conduction, while in N-channel, electrons are majority carriers which allows for conduction across the channel. At first, in the P-channel, MOSFET with no voltage applied between source and drain, electrons and holes at the junction recombine, forming a depletion region which prevent electrons or holes jumps. When a small voltage is only applied between the source and drain, the electric field will be formed between the source and drain, facilitating electrons jump from drain to source, allowing small conduction of current. But when a voltage is applied at the gate, the formation of electric field changes. This facilitates electrons to move from drain to source and gate to source, hence increase in amplitude of current across source and drain. Hence majority of electrons in N-substrate moves towards the base of the MOSFET structure, due to positive potential connected towards the base. This facilitates holes to spread across the channel, due to negative potential at the gate. Hence this enhancement of the holes at the channel near the gate is called enhancement mode. But when potential at the gate is reversed, the electric field formed from gate terminal is reversed. Hence electrons moves towards the base. This facilitates in decrease in the number of holes in the channel, hence called depletion mode, since holes have been depleted in the channel. Similarly, in N-channel, both depletion and enhancement mode takes place, but here, the electrons are majority carriers, which facilitate conduction across the channel. At first, when no voltage is applied at the terminals of source and drain, at the junction, electrons and holes recombine, forming a depletion region which prevent further electrons jump. When a voltage is applied between source and drain, an electric field is formed which facilitate electron flow across the channel. But when a voltage is applied at the gate, electric field is formed across the gate. Electric field is formed such that gate terminal becomes positively charged and base of the structure becomes negatively charged. Therefore substrate holes moves towards the base while electrons moves towards the gate. This facilitate the electrons to fill near the gate, creating a channel with electrons. Hence, this increase in electrons at the channel is called enhancement mode. But when negative potential is applied at the gate, electric field is formed such that the holes in the P substrate moves towards the gate, and electrons near the gate moves towards the base of the MOSFET. This facilitates the reduction in number of electrons at the channel, hence is called N-channel depletion mode. Then characteristics of MOSFET are: 1. It is a tri-terminal. 2. It is unipolar. 3. It is controlled by voltage. 4. It is a high input impedance device. MOSFET can be used as a switch to control the flow of current. When the gate voltage is 0, the channel is not formed, and no current flows between the source and drain. When a positive voltage is applied to the gate of an N-channel MOSFET or a negative voltage is applied to the gate of a P-channel MOSFET, the channel is formed and the current flows between the source and drain. MOSFETs can also be used as amplifier to increase the strength of a signal. When a small voltage is applied to the gate, it can produce a large current in a channel between source and drain. This property makes MOSFETs very useful in electronic circuits. Advantages of MOSFET. 1. It is used to work at a greater efficiency, but with a lower voltage value. 2. As it has no gate current, so due to this, it gives a high input impedance, which produces a high switching speed. Disadvantages of MOSFET. 1. It is susceptible to damage due to its thin oxide layer, which can get damaged because of electrostatic charges. 2. It gets unstable when a voltage gets overloaded. Difference between BJT and MOSFET. 1. MOSFET is N-type and P-type, while BJT is NPN and PNP. 2. MOSFET is voltage controlled, while BJT is current controlled. 3. MOSFET has high input resistance, while BJT has low input resistance. 4. MOSFET is used in high current applications, while BJT is used in low current applications. Applications of MOSFET. 1. Used as inverter. 2. Used in digital circuits. 3. Used as a passive element, like in an inductor, resistor, and capacitor. 4. Used as a high-frequency amplifier. 5. It is used in electronic DC relays. 6. It is used in SMPS. 7. It is used as a switch and in amplifying electronic signals in an electronic device. I hope you found this video useful, and if you did, kindly subscribe, like and share. And see you in the next one.